Alright, so today is essentially a continued review of rhombus, rectangles, and squares. Mostly because now you're going to do the reverse. You're going to have to try to prove that something is a rhombus, a rectangle, or a square based upon your knowledge. And so let's look at the review. Quadrilateral is a polygon with how many sides? Awesome. Cross out the figure that is not a quadrilateral. There's only one. Which one are we crossing out?
I'm not sure.
How about the pentagon? Why is that one a quadrilateral? Because they just care about four sides, right? Nothing said it had to be a parallelogram or anything like that. So today's definition is a diagonal. And so we've already talked a lot about diagonals, but a diagonal has to come from two vertices of a figure and go through the middle or some part of that polygon. It cannot be a side of the polygon. Circle the polygon that has no diagonal. Which one might that be? Pentagon has a diagonal. Look at the pentagon up here. I can draw a diagonal from here to here. So pentagon does have a diagonal. Here's a hexagon down here. Doesn't a hexagon have at least one diagonal? It's not those two. The triangle has three sides and it's impossible to draw a diagonal through a triangle. Remember, your diagonals create triangles. And so it makes sense that triangle would be the only one that has no diagonals. The diagonal has to go from vertex to vertex and not be a side. Circle the polygon that has only two diagonals. Well, let's look at the pentagon. So let's go up here. I know this is a pentagon. I can't draw a diagonal from here. So this would be one diagonal, two diagonal, and can't, there we go, there's two. Now, you might be thinking, so the, where we go? So the pentagon has two. So that appears to be the answer. Let's look at the hexagon. There's a diagonal comes from, well, it depends on how you look at it. So we're going to look at it that all are diagonals. Because normally we'll go just from one vertex out and see how many we can create. But if they're looking at the quadrilateral, there are two diagonals of quadrilateral there. And so let's look at all the diagonals that can be formed. So here I get two from this vertex. How many from this vertex? Two. So how many are going to be total in here? 10. So there's actually 10 in here, right? 10 total, if you go from all the vertices. So with the quadrilateral, we just showed that there's only two. Triangle, there are none, right? What about a hexagon? Look at this hexagon. I can draw a diagonal from here to here, from here to here, from here to here. Now, would any of those diagonals ever be the same, though? Even though we said there was 10 with a pentagon, look what happens if I change color. And I'm going to draw diagonals from this vertex right here. Doesn't that become the same diagonal, that one? That one, so some of them are doubled up, aren't they? So the pentagon really isn't going to have 10 total, but it certainly has more than two, doesn't it? And the hexagon is going to have the same problem. So I can get 3 from each vertex. But again, if I draw a diagonal from this vertex down here, there's one that's shared. So I really only created 2 more from that one. So the hexagon has more than 2. So your quadrilateral is the only one that has exactly 2. You mean like from the side itself?
Yeah.
What do you mean? Like, I can do it from here as well. I just chose not to.
Okay.
Yep, I can do them from all vertices. And I just did it from 2 lines. This says draw the diagonals from one vertex. Oh, it's just from one in each figure. Well, we already messed up that one. So I'm going to cover that up. Because I only want you to draw it from one vertex. Alright, so from one vertex, that's what this one looks like. And then on this one, choose any vertex you want. So this one had 2. How many? This was how many sides? The first one. How many sides? 5 sides. And then it had 2 diagonals from each vertex. So 5 sides, 2 diagonals. This one has 6 sides. And it had 3 diagonals. This one has how many sides? 8 sides, right? And so then from a diagonal, what do you propose I can draw? 5 sides 2, 6 sides 3, 8 sides is going to be is there? 1, 2, 3, 4, 5, 12, 2 pieces. And so because it's not meeting my pattern. So that makes sense that it would be 4 diagonals. Do you see a pattern for me? What's your pattern for me? So if I have n number of sides, how many diagonals am I going to have? 5, 2, 6, 3, 7, 4. Is there a common consistent difference there? What's the difference between 5 and 2? 3. 6 and 3? 3. 7 and 4? 3. So if I had a 10-sided figure, how many diagonals would there be? 10-sided would give me 7. So wouldn't n minus 3 equal your number of diagonals? So we've just created a new formula should you need it, n minus 3. And the figure doesn't have to be regular for that to occur. All right, so flip. So we have a zillion new theorems. That might be an over-exaggeration. Thankfully, right? So if the diagonals of a parallelogram are perpendicular, so we're looking at diagonals are perpendicular, then the parallelogram is a rhombus, at the very least. It could also be a square, but at the very least, that belongs in a rhombus. Then if one diagonal bisects a pair of opposite angles, then it's a rhombus. And it just means one diagonal to bisect a pair of opposite angles because in a rhombus, all angles are going to be equal. That's not necessarily true. Can you think of a rhombus? Could you create a rhombus where all angles are not equal? When are the angles equal in a rhombus? Aha, when it's a square. So number 7 says, insert a right angle symbol in the parallelogram to the right to illustrate theorem 616. Immediately, whenever I'm told I have a rhombus, you've got to make that connection. It's the easiest one to miss, that those diagonals are perpendicular. And it creates these lovely 4 little right triangles in there. Number 8, if ABCD is a parallelogram and AC is perpendicular to what? What would AC be perpendicular to? It's going to take a long time if you guys don't cooperate. BD. Then we have a rhombus. Same thing, the quadrilaterals of parallelogram, if angle 1 is congruent to what? Angle 2, and angle 3 is congruent to angle 4. So there's your one pair of angles bisected. You don't have to prove those ones, just those ones. And so we'll add that to our list here in a minute. And then theorem 618 says, if the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. And so we had that yesterday. So insert congruent marks at the right and right angle markers to illustrate this theorem. So these pieces, by the way, would all be equal, because in a rectangle, not only are those diagonals congruent, but they do bisect each other. And in addition to that, that rectangle has 4 right angles. Are the diagonals perpendicular in a rectangle? When are they perpendicular in a rectangle? When the rectangle becomes a square. So sometimes the diagonals are perpendicular, but it's only when that's a square. So if ABCD is a parallelogram and BD is congruent to what? What would BD have to be congruent to make it a rectangle? AC. Then we have a rectangle. Circle the parallelogram that has diagonals that are both perpendicular and congruent. Which might that be? Only this way. Because the perpendicular comes from what? What characteristic does that come from? The rhombus. And the congruent comes from what? The rectangle. Just like you take characteristics from mom and dad to create you, the square was created by its characteristics of its mummy rhombus and its papa rectangle. All right, problem 1. A parallelogram has angle measures of 20, 160, 20, and 160. And all they've told you so far is that it's a parallelogram. So we know all the things there are to know about a parallelogram. And it says, can you conclude that it is a rhombus, a rectangle, or a square? So let's start off with drawing a picture of a parallelogram. Bless you. I'm a little off, but we're close enough to go. So I'm going to label my 60-degree angles would be here. I'm sorry, 20. How about 20? 20 would be here, and then that would be 20. And this would be 160. Obviously, we're a smidgy off, but who cares? Is it possible for this to be a square? Let's just go backwards first. What would be required of a square and a rectangle for that matter? Right angles. So can we conclude that it cannot be a rectangle or a square? Could it be a rhombus? It is possible for this to be a rhombus so long as what? All 4 sides would be equal, or we could prove that the diagonals are perpendicular, or that we could prove that one diagonal bisects one set of the opposite angles. Are we able to prove that here at all? Yes? How? Can we prove that? Follow the questions here. You do or do not know the lengths of the sides of the parallelogram. True or false? Do or do not? I do not. I don't know the lengths of the sides, right? I know all that I know. Whoops, it's over here. All that I know are the angle measures and the fact that it is a parallelogram. So the fact that it's a parallelogram, I can mark this and those for sure. And I know that the diagonals do what in a parallelogram? Bisect each other. That's nothing to do with the rhombus. Okay? So number 15, you do or do not know the lengths of the diagonals. Do I know the lengths of the diagonals? I do not. Number 16, the angles of a rectangle are all, we already talked about that, right? And the angles of a square are all right. So can we conclude? Yes or no, that it's a rhombus? A rectangle or a square? No, I don't have enough information. No, there is not enough information given. So you can't make an assumption. Could it have been? Yes, but they didn't give me enough information to make a conclusion. So for what value of y is parallelogram DEFG a rectangle? So y is associated with a side length or an angle? A side length. And if this were a rectangle, what would I know about these pieces? They would be congruent. So we're going to set them equal to each other. I'm going to ignore what they put in here. So we're going to set them equal. And we're going to solve for y. So if y has a value of 4, it will make those pieces of the diagonals congruent, which would then prove that the diagonals bisect each other, which then proves that we have a rectangle. And then their question says here, for the parallelogram to be a rectangle, the diagonals must be congruent. And we already answered that question. So we know all that. Problem 3. Suppose you are on the volunteer building team at the right. You are helping to lay out a square play area. How can you use properties of diagonals to locate the 4 corners? So they have two, first of all, what would they want to make sure those diagonals are? Congruent. And then secondly, what would they want to make sure that they've done with them? What do you know about the diagonals in a square? So the diagonals in a square do what? They are congruent. They bisect each other. What else are they? Think rhombus. What else are they? Nope. They're perpendicular. Diagonals are perpendicular to each other. And then this probably isn't helpful, but don't the diagonals bisect opposite angles? So if they're going to do that, my suggestion would be that they make sure that the diagonals are perpendicular to each other and that they're congruent. If they do those two things, they're going to have no issue making a square play area and finding those vertices. All right, flip it on the back, and we don't have to answer these questions because we just did. So we're not going to answer those. Then you do the lesson check. do the lesson check, and then I want you to compare those around you. Compare yours with those around you. All right, you ready? Let's see how you did. And then I wrote next to this where that particular characteristic came from, where it started from. And so the first characteristic, diagonals are perpendicular, was first seen in the rhombus. It is not true of a rectangle unless the rectangle is a square, so it's in the rhombus and the square. The second characteristic, diagonals are congruent, where it was first seen in the rectangle. So it only occurs in the rectangle and the square. It would occur in a rhombus if the rhombus is a square. So that's why they check mark that rhombus. And C, diagonals are angle bisectors, is first seen in the rhombus. So it occurs in the rhombus and the square. And then D, the diagonals bisect each other, comes from the parallelogram. So that's why the rectangle, the rhombus, and the square all have that. And diagonals are perpendicular bisectors of each other. That's not specifically a characteristic that we have listed up here, but if your diagonals are perpendicular and they bisect, that's seen in both the rhombus and the square, and we get the bisecting from the parallelogram and the perpendicular from the rhombus, and combined, you see it in the rhombus and the square. So you notice the square has every one of those properties for the diagonals. So there's a lot of stuff to know about the diagonals in a square. And the rhombus has quite a few of those as well. So anytime you see a rhombus or a square, think you know a lot of stuff about those diagonals. And then the lower you get down on this diagram here, the more characteristics each of those has. So the square has a lot of stuff that you know about it. Any questions? Hold that thought for one moment. Let's see if I want to do anything out of your... Oh yeah, no, we wouldn't want her to do anything. Let me ask you the following question. Okay, so let's look at these. You don't have to get your workbook out, let's just look at these. look at number 14. Determine whether the parallelogram is a rhombus, a rectangle, or a square. So let's look at 14. A parallelogram has perpendicular and congruent diagonals. Where do you first see perpendicular? So rhombus. Where do you see congruent diagonals? Why are we packing up? You're supposed to be paying attention. You got 6 whole minutes, 5 now. So we want the most specific. So perpendicular comes from a rhombus. Where does congruent diagonals come from? The rectangle. So what has both? So this is most specifically a square. If you answered this, a rectangle or a rhombus, you would be incorrect. So then, what about 15? A parallelogram has perpendicular diagonals. Where does that come from? So we know at least it's a rhombus or a square. And angle measures that are all 90. So, right, a rectangle, but together it makes that square again. Look at 16. A parallelogram that has only congruent diagonals. The lowest that one is rectangles. So that's all that can be. Then I want you to look at 17.
Will we take just a few minutes outside just to say something?
Okay. Yep. So a woman is plotting out a garden bed. She measures the diagonals of the bed and finds that one is 22 feet long and the other is 23 feet long. Could it be a rectangle? What do you know about the diagonals of a rectangle? They're congruent, so could it be? No. So answer no. Diagonals must be. I still hear packing up. I don't want to hear one more zipper or one more paper shuffle. I already know all this information. You all that need to know it. What about this one up here? You skipped it, I skipped it. A parallelogram has perpendicular diagonals. Where is that seen? Rhombus at the very least. And angle measures of 45, 135, 45, and 135. So what does that make that? A what? It can only be a rhombus. It can't be a rectangle because a rectangle is what? All 90 degrees, right? So at least because of the perpendicular diagonals, it's a rhombus. If it were a square, these would all be 90, 90, 90, right? Last one. A man is making a square frame. How can you check to make sure the frame is square using only a tape measure? Well, all sides are equal. We're going to get you to a rhombus. Oh, we can't check angles with a tape measure.
All of the diagonals.
The diagonals are congruent. I can't check perpendicularness, if that's a word, with a tape measure. So the only things that I can check would be 1, all sides congruent, and then 2, the diagonals are congruent. If I hit those 2 pieces, all sides congruent makes the rhombus, the diagonal is congruent makes the rectangle, and if you have one characteristic from each one of those, you have a square. In order to have a square, you have to have at least one characteristic from that rectangle and one characteristic from that rhombus. And so now we're done and you can